Hi and welcome back to my channel Machine Learning with me. So before getting started with the linear regression algorithm today, let's try to understand the machine learning life cycle. Okay, so in machine learning life cycle, we do have uh, we start with gathering the data. We'll try to gather the data from different sources. Okay, that's the first stage, and next is data preparation, where you'll try to handle the missing value or the null values. Okay, analyze the data. Here we'll try to see the relationship between the target or the dependent and independent variables in the data set. Then we'll try to build a model, and we'll try to validate it. If the model is performing to our expectations, uh, then we'll try to deploy the model. Okay, so let's get started with linear regression. Okay, uh, linear regression is used to predict the value of variable based on other value. In this video, I have taken an example data set from the Kaggle. It's salary data. Okay, we only have two columns in it. One is years of experience and other is salary. So in this video, we'll try to predict the salary from years of experience using linear regression. Okay, so if there is any one if there is only one independent variable which is used to predict the dependent or target variable, then we say it's then we can say it is simple linear regression. So the salary data is the best example of simple linear regression we are trying to solve here. Okay, we only have years of experience. There is no other attribute such as name of the person or the age of the person. Okay, there is only one particular column, that is years of experience, in order to predict the salary, right? This falls under simple linear regression. Let's say if there are one or more variables such as in order to predict the house price, what do we need? Size of the house, lot size, number of garages, car garages, number of baths, number of bedrooms. All these are many all these are the attributes which are dependent uh, on the target variable, that is price. So that sort of problem comes under the multilinear regression. Okay, what is the basic line equation? That is y is equal to mx plus c, right? Or here I've taken instead of m I have taken b. So don't be confused, because we tend since our childhood we did learn y is equal to mx plus c, so just don't get confused with the values. Okay, so y is target variable, x is input variable or the feature, number of bedrooms, number of baths, or here in our case, years of experience, right? And x is the coefficient of the feature, and c is the intercept of line. So before we begin, I am assuming that uh, you do have at least the basic knowledge in Python programming language, and also it would be great if you do have uh, if you are a bit handy in using these packages for data manipulations, or such the package with pandas, matplotlib, and the very famous Python package sklearn or a scikit-learn, right? It would be great if you do have it's an advantage. Or just don't worry, just stick with me. By the end of the video, you'll just uh, get the basic of how are we trying to implement the linear regression in order to predict salary. Okay, you'll just get to know the different stages in machine learning we are practically going through here. Okay, just stick with me. So firstly, we will try to use pandas to read the data file. Here my data file is salary data, which I pulled from Kaggle. It is in the form of CSV. So I'll say pd.read, okay, CSV. If it's the Excel file, don't worry. If it's an Excel file, you can just say panda.read Excel. As it is CSV, we'll just enter CSV. Okay, we'll run it. There you go. So here we are trying to print only data.head. Data.head is nothing but the first few rows of the data frame. Okay, if you call data.tail instead of data head, you will get the last few columns of data, okay, the last few rows of data. There is also, in order to call number of rows, you can also limit it using 5 or 6, any specific number, right? If you see, this is very similar to the SQL. At least if you do have the SQL knowledge, what to use, how to use it, right? We write a select statement, select star from table name, right? And we use limit, right? We use limit 5. Now, pandas is very similar to SQL, so it will be very easy to learn pandas and implement it. So don't worry about it right now, so just follow me. Now, after reading the file, I'm trying to do some kind of exploratory data analysis. Let's find if our data set has any missing values. Okay, for that I'm using the name dot is null. Is na is nothing but if there is any null variables, it's gonna pop up, and we are trying to uh, you know count it using the sum function. So that's great, right? We don't have any null variables right now. So let's move on to the next step, that is, let's try to find out what is the max, what is the minimum values and maximum values using data.describe. Okay, in pandas you will have this describe function where you can just use it to get the whole description of the statistical description of the data set, right? Here you can see count, mean, count, you see here 30, so there are 30 rows. And you can see the mean, standard deviation, minimum, and percentiles max. It's this is very powerful. Pandas is very powerful tool, which you can see whole lot of statistical descriptions over here. Then let's try to plot years of experience and salary using matplotlib. Okay, if you could see, there's a straight line, or there is a linear relationship we can see over here for years of experience and salary, right? So this is where you will get a basic idea. Okay, let's try to implement linear regression. Maybe that's a good way to predict salary. If you see any other kind of relationship, then there is a chance where you use another regression algorithms like lasso, ridge, logistic regressions. You need to do exploratory, you need to understand the relationship between the target variable and independent variable in order to solve the particular data problem. That's very important. Now let's try to split the data set. Okay, in our data set we do have 30, right? 30 rows. I don't want all the rows. I don't want, I just want a segment of data set where I want to train my machine learning algorithm, uh, and then I want to test it with the other segment of data. So here we are just trying to extract the values into x. Okay, let's see x and y. Okay, here we have extracted the values from the data frame in the form of array. Okay, uh, now we'll try to train and test. Okay, now this is the first stage where we are using sklearn package. In sklearn, we do have a particular submodule named as train test split, which is inside the model selection. Okay, what is train test split? How does this function work? Okay, instead of manually doing the manually dividing or manually splitting your data set, you can use this powerful package where you are the input variables are, you are giving the x and y and test size. Okay, the default test size is 50 and 50. If the data set size is of 30 rows, then it's going to split the data in 15 and 15. But I don't want that to happen. I want more training data, so that my model could perform well. I could get the best fitting model. So I am trying to take here 1 by 3 and random state is nothing but the data doesn't divide in the particular order. Okay, the data doesn't divide in particular order. It shuffles randomly. That's a good way to train your model. So here I got x train and x test, y train and y test, where in order to understand, x train is nothing but uh, x train is the years of experience. So 75 percentage of the data is stored in x train to train the model, and the remaining 25 is to test. Okay, so y train and y test. If you remember, in the previous video of machine learning, basics of machine learning, I explained you linear regression falls under supervised learning, right? Where you do have labels. So y is nothing but the labels, right? Or we can say it does have the predicted, our machine learning algorithm does know what to predict. So here, in the similar way, we have split that, x train and x test. The same thing we are doing with the salary. We are trying to split it 75% to x train and the remaining 25 into y test. Okay, let's see. Yeah, so if you could see, these all values are years of experience loaded into x train, and in the next variable, this is we are saving it to validate our model. Okay, let's try to build the linear regression model. Okay, from sklearn, from linear model, we are trying to input linear regression. Okay, so I'm calling the linear regression model function. Okay, I'm naming it as HR because in companies we do see HR are the ones who try to negotiate the salary to us. So I just named it HR. So let's then I'm fitting the model with x train and y train values. Now the linear regression is trying to learn years of experience and what do you say and the salary, right? The salary. So let's train it. Our linear regression model has been trained now. Now let's try to predict. Okay, in order to predict, you can just call linear regression dot predict. As we have already saved this model into HR, we are simply saying HR dot predict x test. Okay, so we are just saving this one for the validating. We are just predicting from the train. Now let's see the predicted variables. Well, okay, these are the inputs which we have given to the model, and this is what the model has predicted. Okay, so now we need to understand whether our model performed well or not. How do we know it? So in order to do that, we let's talk about model evaluation. Okay, here in model evaluation, I'm taking the metric as mean squared error. Mean squared error is nothing but the actual salary value minus the predicted salary value divided by the total number of rows or size of the data. Okay, now from sklearn dot metrics, I have imported mean squared function. I have evaluated between the y predicted and y test. Okay, y test is nothing but the actual values from the data set. Okay, and y prediction is nothing but the predicted value by the model. So what we are doing is y predicted minus y test divided by number of data points. So this is, sorry about that, this is the root mean square value. If you ask me, hey, what is the best root mean square value in order to decide this is the best model. There is no specific value. Lower the MSE, better the model is performing. So here we can see y predicted and y test. We have given okay. So I'm just comparing between the predicted prediction values and the actual values. If you see the first input from the X-train from the prediction is something around like 40,835, but the actual value is around 37. It's not bad. It's close enough, right? So okay, in the beginning we already discussed the basic algorithm, right? Y is equal to mx plus c in SLR, right? We are going to apply if and linear regression if and only if the correlation or the relationship between the target and the attributes tends to be a linear relationship. Then we did build the model. We did validated it with MSC. Now let's try to plug in the let's try to see what is the intercept and coefficient from the model. Okay, intercept of the model is around something 26,000, and coefficient of line, this is nothing but coefficient of the x variable, that is coefficient of years of experience. Okay, now we'll try to plug in these two values in y is equal to mx plus c formula, and then we'll try to see we'll try to prove whether this linear regression algorithm does follow the basic formula. It does follow, but in order to understand, just to get to know the deeper understanding of linear regression, I am trying to plug in the equations again from the scratch and see the input. Okay, in the x test, which is the input for the testing variables, let's try to see with the first input as 1.5. Okay, when we try to predict this from the x test, right? When we try to predict from the x test, what was the first value it got? 40,835, right? So let's plug in this intercept and coefficient, that is y is equal to mx plus c. Okay, now let's see what is the y predicted value. Y predicted value is 40,835, right? So this is how we are trying to predict the salary from years of experience, right? So this is the end of the video where we're going to I'm going to conclude the simple linear regression. In the next video I'll come up with the multilinear regression with an example data set. Maybe I could pick our classic example, the house price prediction. We'll go through the same exploratory data and analysis, and then I'll try to explain you all multilinear regression. For now, I'm hoping that you all did get a basic understanding of linear regression and what are the packages we have used in Python to do it. Pandas for data handling, reading the data file, sklearn in order to call linear regression, in order to split the data model, split the data set, and matplotlib in order to plot and see the relation between the target and independent variables, right? Dependent and independent variables. So yeah, try to implement this with any other kind of data set. Try to practice it, and practicing makes you a bit better here in machine learning. So today we have started with linear regression. Go to Kaggle, download some kind of data set and try it in the Jupyter notebooks. Okay, all right, thank you.